So we have a drag tire or a drag racing car, and we have force normal. This is the free body diagram. Force of gravity, we can say mg. And then we have a force of friction in the positive x. So we can say sum of forces in the x direction is going to be equal to ma in the x direction. And this is going to be equal to mu sub s f sub n. And this, because this is on a perfectly horizontal plane, we know that rather m sub a of x will equal force of friction, which will equal mu sub sfn. However, here the normal force is equaling the force of gravity because it's on a perfectly horizontal plane. This is not on any sort of incline. So we can say that max equals mu sub s mg. The m is going to cancel out, and we're getting that a sub x equals mu s g, and this is going to we can actually solve for mu sub s, and this is going to equal a sub x divided by g. Now, we don't know the acceleration, so we have to solve. So delta x equals vx initial t plus 1/2 of at squared, and we're solving. We know that vx initial is 0, and we're solving for a. So a is going to equal 2 times delta x divided by t squared. By t squared. And so we can say that mu sub s, or the coefficient of static friction, is going to be equal to 2 delta x divided by t squared g, and this will equal 2 times 1,000, so a kilometer, or 1,000 meters, and then divided by t squared. T is going to be 12 squared, and then times 9.8, and we find that the coefficient of static friction needs to be a 1.4. So this is huge. This is a coefficient of static friction above 1 is going to be huge, because this essentially means that the force of friction is actually going to be greater than the force of gravity, which in that case is really is just very, very high. So you would have to there would have to be a very rough surface, and your tires would have to be made of some special material in order to get your coefficient of static friction up this high. So our final answer is, again, 1.4. That is the end of the solution. Thank you for watching.